Thank you, Dr. Yokomatsu, Professor Norio Okada, Professor Titano, friends and colleagues, many of whom I recognize in the audience. It's a great honor to be here at Kyoto University once again. So I'd like to also express my gratitude to Kyoto University, Bosai Kenkyosho, and also to the Japan Society for Promotion of Science Eminent Scientist Award. It's a real honor to be here today. Feel free, by the way, to ask questions any time as I go along, or you may have comments about the presentation. Now, whenever I start a presentation, I like to have a little quiz. There's a person up there by the name of Mario Molina. This photograph was taken in Puerto Vallarta in Mexico in June. He is one of my 3 favorite people from the 20th century, and I think that they did perhaps the most important thing that happened during the last century. Does anybody want to guess what this person did? Anybody in the audience? I have a prize here if you get it right, just to see if you're alive. I think I'll give you a hint. He was a Nobel Prize winner, but does anybody want to guess for what? Okay. If you think of it as you go along, please let me know. You'll still win the prize, but we'll come back to him later on. But a very nice gentleman. So what is the problem? Here it is right here. Geological evidence shows that higher CO2 levels in the atmosphere increase temperature and drive climate change. And of course, it's having destructive impacts on both our societal and natural systems. And what we need then is dramatic reductions in CO2 and other greenhouse gases immediately. We need CO2 levels below 300 parts per million. This is the latest from the scientists who are working very closely in the physical aspects of climate change. We need about a 90% cutback in fossil fuels emission, or we could be in serious trouble. The climate system may jump to an irreversible situation where it will never cool down again, at least for a few 100,000 years. So this is a very serious problem. I'm proud to be here in Japan because I believe the nation of Japan is the world leader in this area. So it's a real honor to be here because of that. So what's happening? In many ways, the problem with climate change is within ourselves. And there's a famous fable called Tragedy of the Commons fable. And what happened, as you can see up here, once upon a time there was a farmer. He released his cow into the commons. This was common land in England that could be used free of charge by the poorer people. And then another farmer released his cow. And then another farmer did that. And then one farmer may release a few cows into the commons. And eventually, the grass commons was destroyed. They ate all the grass, the rain came, it washed the topsoil away, and that was what happened. So it was sort of individual self-interest of the farmers that caused this problem. Let me try another quiz. Who was the author of that paper on Tragedy of the Commons? Does anybody know the name? Hiro, go ahead. Well, anyway, we'll come back to it. If you think of the name, let me know. A very famous paper. But what happened here, it's a similar thing what's happening with climate change. You might want to call it tragedy of the atmospheric commons. So the nations of the world are knowingly degrading the atmospheric commons. Notice the word knowingly. There's not a single leader of a nation in the world today who does not know that they're causing very destructive damage to the atmosphere. Yet, more or less, they're doing absolutely nothing. And so what they're really doing, they're playing what is called the self-centered version of Prisoner's Dilemma's game. This is where you have to decide, am I going to cooperate with somebody else? If I cooperate, I'll do better in the long run. But if I, in the short run, think of my own self-interest, well then, I think of only the short term and gain at that time. So really, it's the self-interest or selfish version of Prisoner's Dilemma game. So in a sense, selfish human behavior will destroy society via irreversible global warming and climate change. So you can even argue that this disease that's causing climate change is simply our human nature. And we have to, because we can think, hopefully, and be rational, somehow overcome our basic human nature. And this is taken right up through society, right to the national level. So we have to recognize this is sort of a human thinking problem, climate change. So can society escape self-destruction? Well, Mark Twain, a famous American writer, wrote, I've been through some terrible things in my life, some of which actually happened. We often have nightmares at night and we think of the worst case scenario, and of course it never comes about. But the trouble with climate change is we know it's going to be terrible and we know it's going to happen, and yet we're doing almost nothing about it. Here's an expression from the Titanic when Professor Okada was visiting Waterloo in a special scholar position. Last year we went to a museum, and here's what they said about the ship, the Titanic. Unthinkable that it was unsinkable. Now, planet Earth, thinkable that it is sinkable. We know that the atmospheric commons could be severely damaged or possibly collapse. So now here's an interesting parallel for these two roosters. This was taken, by the way, down in Mexico, and those roosters have a choice. They could sort of, stay apart like this. Their masters could keep them apart, or, they could fight and one of them loses. It's to the death. So the roosters have a choice. They could sort of say, well, aren't we both better off if we run away and forget those two masters who control us? And the answer is yes. The roosters are better off not to fight. And likewise with other nations of the world, we're better off to cooperate and not try to grab all the short-term wealth for ourselves. And we can do that by cutting back on climate change. Well, I'm going to be somewhat critical during the presentation. And I think when I visit another country, you don't want to be critical of that country. So let me be critical of my own country, Canada. The first one is actually something positive. We want to close down a coal-fired generating station. This is responsible action by Ontario. China, by the way, as you know, is bringing into operation one coal-fired plant per week. This is enormous destruction to the atmospheric commons. Well, we're going to have to show some leadership, and at least there's a little bit here in Ontario. Here's an example where it could do a better job. This is exploitation of Alberta's oil sands. How many have heard of the oil sands in Alberta? Anyway, they're massive, and it's the largest reserves of oil in the world. They're just massive in size. I'll come back to that in a few minutes. Let's take a look then at the good news. Here is something that Canada actually did, which I think was very responsible. So the Lambton Generating Station, this is owned by Ontario Power Generation. This is like a prefecture in Canada, the province of Ontario. It's coal fields, so this is bad news for the atmosphere. And it's located in Sarnia. So there are 4 generating units that can produce something like 1,900 megawatts of power. So actually, the petrochemical industry is quite large in this area. This is actually very close where the modern era of oil started. In 1858, they had the first modern pump to take oil out of the ground in Ontario, close to a city called Sarnia. 1 year later, it happened in Pennsylvania in the United States. Penn State Oil was started. But the whole revolution actually started here, which is quite interesting. Okay, so anyway, what they want to do then is close down this plant. This is the plant right here. This is really just water vapor. That's going to be shut down very shortly. This is along the St. Clair River. On the far side of the river is the United States of America, and Canada on this side. And there, once again, you can see this coal-fired plant at Lambton, Ontario. Now, does anybody recognize this? So that's the good news. Here's something that Canada did. It was responsible. And there'll be other coal-fired plants that will be shut down. Anybody recognize this mess right here? Anybody know where this is? Anyway, these are the oil sands of Alberta. As you can see here, these are toxic tailing ponds. This is the Athabasca River. Here's some sort of chemical factory right there. And here they're actually taking the tar sands from the surface. It's simply oil mixed with sand. You can see along the river here where naturally the tar or bitumen actually leaks right out of the soil, and the Athabasca River is right there. So here's the situation in Alberta, Canada. Here's the province of Alberta. Here's the country of Canada, and you can see it's located right here. You can see that that takes up a fair size of Alberta. We have the Athabasca oil sands area. We have another 2 sites, Peace River and the one right down here. So there's actually 173 billion barrels recoverable. That's actually been upgraded to a much higher number. It's as much at least as in Saudi Arabia and the Middle East. Extraction, 20% by mining. That means we dig a big hole in the ground, haul the sand away with the bitumen in it, then maybe use centrifuges and other techniques to remove the bitumen. And then 80% in situ. That means on site. What happens is they pump steam underground under high pressure. It pushes the bitumen to the surface, and then they haul it away. This is what they call in situ. So there's about 140,000 square kilometers, and 500 square kilometers have been surface mined already. So that's a fair-sized piece of land, 500 square kilometers. Here's what the bitumen looks like. You can see it just looks like wet mud if you hold it in your hand. And it's a mixture of sand, clay, water, and bitumen. This is sort of like a tar-like oil. It's very carbon-rich, very viscous. About 1 to 20% is actually something that can be turned into oil. Here's another photograph. You can see the scar that it leaves on the surface of the Earth when they actually remove this. This is a very famous Canadian scientist by the name of Schindler. He's been very critical of how they've been handling this whole problem of the oil sands. Just losing this on my ear here. Let's put it on. There we go. Yeah, so there he has a fish that has a cancerous tumor because of pollution in the river. So a little bit more details here. It was actually started in 1967. It's extracted by the sands, as I mentioned, by surface mining in situ. Very energy intensive. So we have to heat up the water, pump it underground as steam, then push the bitumen to the surface. The amount of water used is something like 2 to 4.5 barrels of water for each barrel of oil. So it actually uses a lot of very valuable water in a dry area of North America. And we have these huge toxic tailing ponds that you saw earlier. So the question arises, is Alberta actually becoming a massive brownfield? That means polluted land. They use that expression for land that's been polluted by industry. It's called a brownfield in comparison to a greenfield. Here are a couple more photographs. Once again, you can see the oil leaking out of the ground. And this is probably close to 100 years old. They've known about this bitumen for a long time. This photograph of people walking along the river. Okay, now we have another problem. One is it's fairly messy, very energy intensive to take this bitumen from the land. We have another problem. This is the problem of the fox guarding the chicken coop. You can see the fox here, and you can see the startled chickens. But what does a fox do? Well, a fox, of course, eats the chickens. It's as simple as that. So you never want a monitoring agency that has this type of characteristic. We have no independent monitoring agency whatsoever in the province of Alberta. Any agencies there are that exist are all controlled by the oil industry. So this is very bad, of course, for the Canadian public because we should have responsible, independent monitoring. Here, once again, then, is a view of the oil sands. And you can see here, this is where they're surface mining it. And this is where it's naturally coming out of the ground into the river. So it's a raw deal for Canada, the oil sands, and it creates an environmental mess. The situation actually gets worse in terms of management by the provincial and federal government. Canada proposes to build the pipelines to ship unprocessed bitumen to the United States and to Asia. There's something called the Keystone Pipeline that's going to be going down the... It's actually going to be going then right through the middle of the United States down to refineries by the Gulf of Mexico. So what's happening then, we're actually losing $60 billion per year of value added. They have the capacity in Alberta, Sarnia in Ontario, Montreal, St. John's in the province of New Brunswick, but yet they've decided that they're going to give away $60 billion a year. This we call very irresponsible governance because we need the value added right in Canada. We don't have the cheap labor of China. We're, of course, a fairly advanced country, just like Japan, but this is our ace card. There's an excellent source here that you might want to take a look on your own. I'll leave a copy of the overheads. But if you take a look at the Canadian Academy of Engineering, they came up with 2 reports called Canada Winning as a Sustainable Energy Superpower. You can download these both free of charge. There's an overview report, and there's also a detailed report that's about 200 pages in length. Excellent report. It's probably the best blueprint that's been made for the future, the economic future of Canada. Down here, there was also an article in the Globe and Mail called Energy Supremacy. This is our main national newspaper, and that took up about 9 pages. And I've been associated with this task force here for about 7 years. So they're taking a look at these problems very seriously. Here's where the pipeline will go, proposed pipeline, from Alberta here, and that actually extends right down to Texas. Here's where it is here going to the Northern Gateway from Alberta to Kitimat, and then it would go by ship to Asia, probably mainly to China, some to Japan, some to Singapore. So here's what it is. It's a bad deal for Canada in the environment. Canada gives away the highly profitable value added, and then foreign countries receive greatly expanded refining industries, new technologies, jobs, and huge profits. So you see there are a lot of serious problems with the oil sands. Now, one reason why these exist is because they didn't really take a systems approach when they looked at the oil sands resources. So that's an example then of sort of a situation that we're handling very poorly within our own country. The first example was closing down a coal-fired plant. I think that's excellent because we really have to close them all down in order to be able to cut back 90%. But then they gave another example which releases a lot of greenhouse gases, and from a societal economic point of view in the long term is very poorly planned and managed. So let's go back to the problem now. So we have then geological evidence shows that CO2 levels in the atmosphere increase temperature and drive climate change. That's a known fact. The science of climate change is about 100 years old, and for the last 20 years, we know that there is a very significant human component. So it has destructive impacts in the societal and natural systems, and we need dramatic reductions of CO2 and greenhouse gas emissions straight away. So as I mentioned before, we need these levels below 300 parts per million. So here's, if you're going to remember one slide in the presentation, here's probably the best overview slide. How are we going to solve this problem? Now, today I'm concentrating mainly on the national and international level. Of course, as you get down to the lower levels where things are brought into operation, there's a lot of good work being done right now. But where we're the weakest by far is actually at the national and international level. Well, first of all, we have to have responsible governance. By governance, I mean policies, bylaws, institutions, whatever it takes to manage the situation. Take a look at it from a system of systems perspective. Everything interacts with everything else. So if we cut down forests to make farmland, that means more greenhouse gas releases. We've gotten rid of an absorber of CO2, the forest. That affects the climate, that affects industry, that affects the economy. Everything is interconnected. So therefore we have to look at it from a systems of systems point of view, but we have to be integrated. We have to go across systems. And furthermore, we have to somehow be adaptive. Things will change in the future, and how do we change our policy and ideas in order to account for that? A very important one right here, it has to be participatory. We somehow have to reflect the value systems of the various stakeholders. Now, what's particularly nice about this is what we really want to do is to achieve desirable system goals such as resiliency, sustainability, and fairness. We want the system to be resilient. And somehow we don't want it to collapse. It has to be able to be bounce back and be robust. Sustainability, that's a trade-off between, of course, the environment and economics. And we have to be fair to the different shareholders who are affected by this. So this overall then is sort of a systems approach to looking at this problem. Now keep in mind that climate change is only one problem that we know of right now. I'm going to mention another one in a few minutes. They're finding out through systems theory that it's very difficult to predict because of synergy across and among systems what could happen next. These chemicals of emerging concern. What type of situation may jump up there? So in all the problems that we take a look at, we have to use this type of approach. And what I'm concentrating on today, of course, is climate change. Just to give an example where this one isn't taken into account, as you know, we have the World Trade Organization. It's come up with fair rules for nations trading with one another. At the time, it looked like it was a very good system. The nations of the world agreed upon it. But the problem is it's unidimensional. In other words, it's only taking a look at profit maximization for the big corporations, and they want a fair playing field for the corporations. Well, the problem with that is, of course, is we know that this is having a severe impact upon climate and many other types of water quality and air quality variables in the earth. So we have to be much more comprehensive. We have to be sort of multidimensional. We have to take into account fairness, economic gain, and everything else. We need a much more integrative and adaptive approach. I think I'll skip this slide here. Here's an example then of a system. I hope you can see that. You can get a copy of these overheads later. Here we have our societal system of systems. We have energy production, agriculture, industry, a lot of infrastructure to support society. Over here we have our natural system of systems, the atmosphere, hydrosphere, biosphere, etc. And these are all interconnected. Now what society does, it takes resources from the natural world, somehow processes and uses them, but unfortunately there are byproducts that get dumped back into the natural system. Well, now for the first time in human history, at least with respect to the atmosphere, we know that we're causing severe damage to the system, and the cause and effect is happening now very, very quickly. The Americans, of course, very unfortunately, have been shocked by Hurricane Sandy, which they think has a very significant human component. The storms and weather conditions are getting more severe and more extreme. And of course, a big one is sea level rises. Now, these squiggly areas, this is the effect that our activities can have. Here it affects our societal systems, but it also affects our environmental systems. The environment is no longer a dumping ground where we can simply put our byproducts back into it. So when we look at any systems problem, we really have to take a look at an integrative whole picture like this. This, of course, is at a very high level, this particular systems diagram. So there, well, here is the answer then. No, well, Molina won the 1995 Nobel Prize. Does anybody want to guess what area? Yes. Exactly. Round of applause for that young lady. Yeah, please come up here. You have to get your prize. Yeah, okay. Yeah. Oh, yeah, thank you. Yeah, go. Congratulations. There we are. Waterloo pin. Yeah. Yeah. She's right. He won the prize for the release of CFCs, which was depleting the ozone layer in the high upper atmosphere. It was himself and two other people who actually came up with an explanation of the chemistry of what is happening, and then they tried to do something about it. So to me, they're probably the three most important people from the 20th century. They probably saved humanity from having very, very severe, let's say, types of conditions on planet Earth. If the ultraviolet light comes through, of course, it's going to kill the plants eventually, which means widespread starvation. So these men did an excellent job. Very nice gentleman here, and he was actually from Mexico. The other two are Americans. So let's take a look then at international environmental treaties. There's no comprehensive international environmental treaty in place right now. There were some successful treaties in specific area. The law of the sea was sort of successful, but in a specific area, the Montreal Protocol on substances that deplete the ozone layer is by far the best treaty that's ever been written. And I would say this is even far more important than what the World Trade Organization does, because it's so centered only on profit maximization, which is causing widespread damage right around the globe. So as I guess many of you are engineers and scientists in this room, what's the best way to come up with a solution? Is there something else that worked well? You know, we built those beautiful bridges in Japan to Shikoku. I'm sure that when they built the various types of bridges, where else in the world do they have them? Let's take a look at their designs, you know, see what happened, and maybe we can modify that somewhat for our own particular designs within a strong earthquake region of the world. Well, the same thing here. Let's take a look. Is there some treaty that's actually worked that we could use to come up with a climate change treaty? And it is the Montreal Protocol of 1987. Just a tremendous success for society. But let's just take a look at what happened in more detail. It's quite interesting. So as Kofi Annan said, the head of the United Nations, perhaps the single most successful international agreement to date. And I have to agree with him. I can't think of something that went bang to solve the problem immediately right around the globe. So what was happening then is the ozone hole over the Antarctic was increasing in size. Luckily, they did discover it. The hole didn't go beyond the point of no return where there was no chance whatsoever of recovering. They discovered it in time. And they also explained what was happening with the chemistry. So what they did is they banned the use and production of CFCs. That was the main culprit. But there are other types of chemicals, too, that are destroying the ozone hole. So they also banned those as they became known. So we would argue this is a model for future environmental treaties, such as the decreasing the release of greenhouse gases. What do we have to do fantastic treaty that Japan is pushing, the Kyoto Protocol, in order to make it effective. Let's take a comparison to the Montreal Protocol of 1987. I think there's some good lessons to be learned here. Okay, so I'll just mention a little bit of the problem. They were discovered in 1928. They had very toxic gases that they used for refrigeration and the manufacturing of styrofoam and other types of products. And they thought, here is an inert type of product, CFCs. The trouble is they evaporate quickly, and when they reach the stratosphere after about 5 years. Okay, now the ultraviolet radiation breaks down CFCs, causing the release of chlorine atoms. And it's the chlorine atom. One chlorine atom can destroy 100,000 ozone molecules. Now, this was completely unexpected. And this is part of what they say now in systems theory. Because we have these complex systems interacting with one another, we're not going to predict everything that can happen. There are going to be a lot of surprises. Something's going to jump out of the box. So we have to have sort of a policy or governance approach to be able to deal with these types of things. So let's just see what happened here. I'll just mention a little bit more about this. Think of the ozone layer like a sunscreen. You go out on the beach, so you put suntan lotion on. Well, that's what the ozone layer is like. So this, I'll skip that definition right here. It was in the mid-1970s that Mario Molina, who you saw a photograph of, Paul Crutzen, and Sherwood Rowland made the case that CFCs are causing ozone depletion. And they were absolutely correct. And then finally, in 1995, the three of them jointly received the Nobel Prize. Like I think it was the most deserved Nobel Prize ever. I can't think of one that's nearly as important as that particular one. Here then is another photograph of our colleague here, one of the Nobel Prize winners, Mario Molina. Here's what it actually looks like, the ozone hole. It was discovered over the Antarctic in 1985. And the record size was almost 30 million square kilometers, 3 times the size of Canada. Now, they've also discovered one, by the way, over the Arctic. So we're not out of the woods yet. We still have to be very vigilant and make sure that we keep cutting back on any type of gas that can cause the ozone depletion. So what we've done is really we've just halted it. We stopped it from growing out of control. We still have a lot of work to do. Now, here's some good news right here. 1985, they had the Vienna Convention for Protection of the Ozone Layer. Guess what? A lot of the nations of the world complained, and environmentalists and everybody else. They said it's toothless expression of hope. That was what they called the 1985 Vienna Convention Agreement. Have you heard that before? I think the critics of the Kyoto Protocol say, well, this doesn't have enough teeth. It's not strong enough. It's not going to work. Well, what you don't do is do what Canada did and irresponsibly walk away from the negotiation table. You have to negotiate and communicate with everybody in order to come up with a good agreement. So we're very disappointed on the behavior of the Canadian government. Hopefully that will change. They have to come back to the table. It's as simple as that. So guess what happened? In 1987, they came up with the Montreal Protocol. It has real teeth to eliminate the release of CFCs. It really worked well. So here's something else that's very interesting. It was strengthened in subsequent amendments. Other ozone-depleting substances were addressed and phased out, and were also phased out just like CFCs. So in other words, think of this as an adaptive governance approach. As we recognize, other types of ozone-depleting chemicals that come about, somehow they're released in the atmosphere. If we know they cause damage, we immediately stop, we ban those also. So that whole idea of adaptive, I think, is very important. And this is certainly an adaptive treaty. It didn't just say this is for CFCs, it's for any type of chemical that they discover that destroys the ozone hole. Here's something else. Notice this. Developing countries were allowed more time to phase out these ozone-depleting substances. So, for example, at that time, well, of course, Japan was a very, very advanced industrial nation. China was just sort of up and coming, and China was given more time to stop the production of CFCs. Have you heard that argument before with respect to greenhouse gases? Well, we didn't cause it. You caused it. You've been doing it for a much longer time than us. Why should we cut back? So you see, you can actually bring this into an agreement, the idea of fairness. We'll take a look in a few minutes at what is a fair agreement for climate change. So a very, very nice example to go by. The Montreal Protocol of 1987. I think I'll just skip it. I was going the wrong direction. Here then is another photograph. Actually, all of them are Waterloo alumni. He actually received an honorary degree from Waterloo, and Jim Tien and Mo Jamshidi. So we had a little bit of a reunion there. Professor Okada is also an alumni. So I would argue, just to repeat, the Kyoto Protocol, which you have spearheaded here in Japan, and you should be extremely proud of and keep pushing hard, it's probably, let's say, at the Vienna stage in its evolution. And I think there's a very strong possibility it could also become just like the Montreal Protocol. But you have to keep negotiating. Here's something very interesting to keep in mind. Once again, we're taking a look at the Montreal Protocol because it's an example that might inspire us to come up with a better Kyoto Protocol. Industry and all governments fully supported the 1987 Montreal Protocol. Some of the big chemical companies said, well, look, the scientists of the world are 100% unanimous that this is causing ozone depletion. Why should we bother to fight against them? These are the world experts. Have you heard that before? 100% of the world's experts are saying that there's significant human impact causing climate change. In this case, industry got on board. Unfortunately, today we have the fossil fuel industry, which is extremely negative and sort of, how should I say it, a lot of propaganda around the world, which is simply lies and falsehoods. It's completely untrue. I think that the right-wing governments, like the previous government in the United States, the government of Canada today, and the fossil fuel industry, they have the opportunity to be on the right side of history. Let's give them that opportunity. You know, of course, if I were, speaking to some of these groups that are against climate change, I wouldn't be quite as to the point as I am right now. But let's not pussyfoot around. We know this is a very serious problem. So let's get them on the right-hand side of history, and hopefully we can come up with an agreement. It has been done before. Well, there are just a few others at Porto Vallarta. He's a president of a university in Hungary. So let's now take a look at some solutions. Okay, I hope I gave just a little bit of an overview of what's going on. All countries of the world are to blame. We're all guilty. The disease comes from inside ourselves. In the short term, we tend to think about our own self-interest. Well, guess what? That's reflected at the national level, too. Countries are mainly thinking of their own self-interest. So we have to somehow overcome it. There's some good news. We've had a very serious problem in the past, the ozone hole depleting gases, and we actually came up with a solution. So let's now look more specifically at climate change. What are some of the governing models that we could use? Now, here I'm concentrating more on the national, international level, because if we don't have an agreement there, no matter what you do locally, no matter how concerned you are, it's not going to have much of an effect. We have to cut back on the big polluters, such as coal-fired energy plants. Well, who's going to shut down the energy plants in China? It won't be an individual citizen. It's going to have to be the central government. And likewise in other countries of the world, including Canada. So here are some of the possibilities. I'm going to explain this one in a minute. I think it's brilliant. This isn't my idea. This was from James Hansen. It's called fee and dividend. There's one called cap and trade. I won't spend much time on it. How many have heard of the cap and trade approach? Okay, well, in summary, it's just simply not going to work. Extremely poorly designed, and it's not going to work. Don't forget, it was designed by the people who caused the collapse of the stock market. So it's sort of like the foxes running out and saying, well, let's also make profits on polluting the place. So, and it actually has a very poor design. You can show very easily why it's going to fail. It's never worked anywhere in the world on any type of problem, period. Okay, down here we could have strict regulations. Well, we still may need some. We call this command and control. But, that tends to make groups wanting to cheat if everything is strict command and control, and often doesn't work. And down here, laissez-faire, well, that's a total failure. It simply hasn't worked. That's what's causing the problem right now. That means do nothing. That's the French. Just leave to be. Leave to me. So let's take a look then at number one here. There may be some time to say in the question period to mention some of the drawbacks, but let's rather concentrate on the solution, fee and dividend. So what happens? Now, once again, let me make this clear. A number of Americans, including James Hansen, are the key proponents of this. As systems people, we can come in and test this out, make sure that it's going to work and all the rest of it. So there's his book right down here called Stories of My Grandchildren. He publishes widely in Science, Nature, Proceedings of the National Academy of Sciences. This is a first-class scientist from the United States. So first of all, then, what are we going to do? We're going to tax carbon at its source or point of first sale. We call that a fee. Now, that's easy to do. We know where the oil is coming out of the ground in the tar sands. We know where our coal mines are. We know where they pump up oil out of the ground, the conventional approach. Extremely easy to do. The bureaucracy is already in place because we have inspectors who go to these locations. We have government agencies available. No new bureaucracy whatsoever. So that's called the fee that's collected there. Then here's a key thing right here. Distribute 100% of the tax uniformly to the citizens of the country. You don't give it back to the culprits who created the problem in the first place, which you do under cap and trade. It makes no sense. This is what we call the dividend. Now, they then, of course, can use that and spend the money however they like. We'll take a look at an example in a few minutes. Now, here's a nice one right here. So that's called dividend. Here, then, negotiate level of tax for each nation. This is called liability. India and China, they come along and say, well, you caused the problem. You've had heavy industry for a long, long time. Why should we have to pay the same as you? And they're absolutely correct. It's called liability. You remember under the Montreal Protocol, the nations that were developing were given longer to stop production of CFCs. Now it's 100% out of production, for example, in China. So it's a good argument. I agree with them. They're absolutely correct. Then down here, we increase the tax over time to bring the carbon use to the desired level. This is called survival. If we don't do it, society is toast. It's as simple as that. So you see it has some very, very nice attributes. Fee, dividend, liability, survival. So very, very simple, but I think clever way to do it. Almost no extra bureaucracy needed anywhere because we can very simply put this into effect. We have the government institutions in place in most countries of the world. So here's an example. This was actually taken then from James Hansen's book, the fee and dividend example. Let's say, for example, they have a tax increase this year. He actually did it for the year 2007, I believe. $115 per ton of CO2. So this could be coal, oil, it doesn't matter, whatever it happens to be. This would increase gasoline to put in your car by 25 cents per liter. For the year 2007 in the United States of America, this would yield $670 billion. Dividend per person, let's say the dividend per person then is $3,000 per year or $250 per month. Let's say each child got half of the dividend, not the full dividend, and the adults got $3,000 each. Well, a family with 2 children would have $9,000 check per year. Now, that family then controls the power. They go out as an individual consumer and decide, well, am I going to pay more money for something that has a big carbon impact, or should I save some money and buy something that's more responsible? And you see the power of this approach. It gives the reward to the citizen, and it also puts the power in their hand. Now, of course, in conjunction with the tax going up, they will have to make sure that the overall levels are decreasing, too. There's a bit of a cap there, too. If it's not quite working, you use an adaptive approach, and you increase the tax more. We have to cut back 90%. So I think this is a very, very clever approach. We could test various versions under this using agency theory and all sorts of things that we do in systems engineering in order to test if a policy is going to work. What will be the effects? What will they be like? But I think the basic components are right there. Here was that conference in Mexico, once again, a beautiful environment. You certainly wouldn't want to see that destroyed. We want them to have a future, of course, and things are looking pretty bleak right now. I mean, if we don't shape up very, very soon, that means within a few years, we better start doing something right now. We're in very, very serious problems. Let's not beat around the bush. I think it's by far the greatest threat ever to face society. There's not even a close second. So you can see down here, they sort of blend in with the environment by having their beach houses there, but how much blending in is enough, how much is too much. Here was a lunch that we had then. This is Molino is sitting right here. We had a very nice 2-hour discussion there about what's going on. His research, by the way, now has shifted over to climate change. He was the one who won the Nobel Prize once again for explaining the chemistry behind the ozone hole creation. So, international fee and dividend, we need a universal carbon tax, but we must have fairness between those who cause the problem, those who are causing the problem, and those who are the victims. So let's take a look at a little bit more detail about what we could do. Okay, let's take a look here. An international solution. Well, the United States and China are by far the main culprits in the world. So, they may have, let's say, bilateral negotiations. It might not necessarily be a convention where you get everybody together like they have so far. And they know that it's going to be devastating to both nations, especially in China, where they have this massive population. They know the effects. I mean, these are smart people, the head of the country. But in my opinion, I think the name of the game by China now is they're taking advantage of the cheaper, very high-skilled, intelligent labor in order to take over bigger control in the different areas of the economy. Then maybe after 20 years they'll say, well, let's all cut back. They're currently the largest producer of solar cells and also windmills in the world, so they're clearly thinking about the future. But this old game we can no longer play. That's fatally flawed because we need cutbacks immediately. We can't wait 20 years for that to happen. So the Americans could maybe have some sort of bilateral negotiations among the two countries, and they could negotiate their respective carbon taxes. So China says to the United States, well, you've been doing it for a lot longer than us. Let's start our tax rate out at, say, 20% of what yours is. But at least with that, you'll be tackling the problem head on. No pussyfooting around like you do with cap and trade. You get in and start solving the problem right away. A direct tax on the carbon sources. Now, this is then where fairness enters. China has an excellent argument, and so does India. This is unfair to us. Okay, so then you negotiate how you do it, just like we did for the Montreal Protocol. China was given a longer time to cut back on the CFCs. So the USA may have a higher fee initially to allow for the fact that it contributed more to the problem. Now, I have a number of other pens I want to get rid of. Since the Industrial Revolution, which country per person or per capita has contributed the most to greenhouse gas releases? Which country in the world has contributed the most per person? Sorry? Nope, wrong. That's wrong. Sorry? Nope, not America. This is per capita. Total volume, you're right, but per capita, no. I gave a bit of a hint when I said the Industrial Revolution. No. China is the biggest culprit today, but in the long run per capita, it's quite low. UK, you're right. Okay, so you have come up here, you get another pen. Well, no, you got to come up and get it. If you answer correctly, you can give this to your, whoever you like. Oh, yeah. Anyway, congratulations again.
Thank you.
You're from what part of India?
I am working in Bangkok. I'm associate professor in Thailand.
Oh, you're from Thailand?
Yes.
Oh, I see. Okay.
I have a diamond in India.
And what part of India? Sorry?
North part.
North part. Okay, good. Yeah. Yeah, well, India, of course, is into a similar situation as China. They were arguing, well, why should we have to cut back as much? Okay, so the United Kingdom, they started the Industrial Revolution about 250 years ago, and per capita, they've been the biggest culprits. Okay, so that's one thing. So we can bring fairness into it. They're right. India and China are right. We should have a lower tax to start with. But keep in mind that that money is paid back to the citizens of the country, so it's to China and India's advantage to increase the tax as quickly as possible, because that then will stimulate their internal consumption within their own countries. So there's sort of a push there that also says, well, don't take too much advantage of the fact that your taxes will be lower to start with. So that's rather nice. Now, there's something that, of course, in game theory we call free riders. The people who come along for the ride and don't really contribute to cut back on CO2. So we could have a low import duty would be imposed on products from a country not having carbon fees. Now, I find this hard to believe, but in his book he says the World Trade Organization actually has rules permitting such duties. I guess they must have had a little bit in there having to do with environmental problems. And exporting countries have an incentive to impose their own carbon fees so they can keep the revenue, as I just mentioned. So there are incentives to make this thing work. It's got a good design. Poorer nations, well, what are we going to do there? Well, carbon taxes, we're certainly going to have to tax their exports to countries. So carbon taxes on imports from the poorer nations, it can be used by the importing nations for development purposes. So let's say if Japan then gets some raw materials from a country that can't afford to clean up, keep that money aside, go back and maybe help them put into place some electrical generation of some type that does not pollute the environment as much. So you can decide how you're going to help those countries. Increased economic well-being coupled with education. Well, there's this whole problem then, of course, with fertility rates. If you look at the underlying problem, let's say it's these huge populations. Well, the fact is as countries become richer, people become more educated, the population will stabilize and then decrease. And we certainly have to have populations much smaller than they are today. So that'll be less stress on the planet. So there are all sorts of good spin-offs of this type of thinking. Okay, let's take a look now at a few other things. Just flip ahead here. So that then is an overview of the fee and dividend approach. I'm not going to go too much into the drawbacks of cap and trade. If you have questions later, feel free to bring them up. Let's start taking a look at a few other aspects having to do with climate change. Here's this famous Keeling curve. So this is measured in the American state of Hawaii. And as you can see, it's sinusoidal. So I guess it's during the summertime when there are more plants in the northern hemisphere. They absorb the CO2, so we have this bit of a decrease. But overall, it's rising. And this is very informative since it's right in the middle of the Pacific and there's very little industry in Hawaii. So this is what you'll often see in the literature. They show this Keeling curve. And they know from the past history of the world that CO2 is the main culprit of climate change. So let's take a look at some of the CO2 levels in the atmosphere. It can actually be quite confusing when you think about the different numbers that are bandied around. So then the parts per million, and often this is the equivalent CO2. So if you release something that also that are also greenhouse gases, this is sort of lumping everything together. The main culprit is CO2. So stable CO2 levels during the Holocene period last 10,000 years, up to 250 years ago. Well, that's, of course, when the British started the Industrial Revolution. They were sort of forced to. They'd cut down all their trees, and they knew that coal had produced a lot of heat, but they didn't realize what a powerful agent it was for industry. Make steam, turn the wheels, then they have these pulleys that would cause machines to run. So the British started that. The Germans were a little bit later because they were actually more conservation-minded. They had not cut down all their trees like the British had. That's the reason why Britain got into it first. So the Industrial Revolution in mid to late 1700, then things started to increase. Now, 300 parts per million, that's the current goal of the climate scientists. They're saying now that it's happening much more quickly than expected. Levels above this could prove to be quite dangerous for the world. So 350 parts per million, this was the earlier level recommended by James Hansen, in 2007. But they've since then said that this is too high. We have to be below 300. 390 or roughly 400, that's the current situation today, and it's rising quickly. So just sort of remember 400 parts per million today. We have to get it back under 300. Let's see here. 450 parts per million, moderate climate change no longer true. Remember, that's the one that they kept bandying about and saying, well, that's a 2-degree C rise in temperature. Well, actually, that's just a fairy tale right now. It's not going to be good enough. So throw that one away whenever you hear your politicians talk about the 2 degrees C. That's simply no longer doable. The consequences are too serious. 550, dangerous level, twice the pre-1700s level. That's the only reason why they use that number, because it was twice what had happened before the Industrial Revolution. So 650, perhaps unavoidable. That's a 4% increase in temperature. It's just runaway climate change. The system could spiral out of control. And let me just emphasize one or two more. This one right here is the one that you'll often hear, 450 parts per million. If you hear your politicians using that number, let them know that's not good enough. We have to get it down to below 400. And also, there's this other argument right now. It's called the precautionary principle. if we think something is going to be dangerous, just to make sure, let's take action to make sure that we do not get into this very tough situation. Because the policy will be adaptive, if you find that the action you're taking is enough, or it's too much, you can release it a bit. You can cut back a little bit. But most serious is if you don't take enough action. So we can be adaptive in our policy. But they're becoming more and more sure that we need much more action than what's going on. Okay, and let's just see here. The disastrous effects of global warming are starting 50 years ahead of schedule. So what you read a few years ago in Science has changed dramatically. And this is about a 90% cutback in CO2 emissions below 300, roughly speaking. Current level, once again, is at 400 parts per million. It may already be past the point of no return. The scientists are arguing about this. There's a lot of uncertainty, but we're certainly very close to the point of no return. Okay, here's a nice pie graph that shows the various sources. Notice that power here takes up quite a bit, 24%. And I mentioned then a big culprit are coal-fired plants. So they're all different areas here where we're going to have to take measures to somehow cut back. Now, here's a very interesting set of 3 graphs. This was taken by from the reference given down here. Notice right here, scientific consensus on anthropogenic, that means human-caused climate change. Now, notice here, 97% of the scientists agree. 3% say no. But they're not saying no, there's no effect. They're just saying we don't see enough evidence to say there's a significant impact. They're not saying what some people who are against climate change will say is, oh, these people are saying it's definitely not occurring. They're not saying that at all. If you're going to speak to the general public, I think we want to use, how should I say it, all of us are guilty of this in the room. We somehow want to use better communication tools. We want to use, let's say, rhetoric or language intelligence. So if you try to explain what I just said there, we all know from hypothesis testing, well, that's not the language that people think in. People think in terms of stories. They think in terms of the language that they hear every day. The response is we're 100% sure that there's a very significant human impact. If you try to explain the small probability we might be wrong, well, the critics immediately use that type of thing. So almost 100% say there is an impact. Here, then, is immediate coverage of anthropogenic change. Now, this is in the United States. Take a look here. When they interviewed people or wrote articles in the newspaper, 28% of the people who they interviewed were the ones who said they were true climate scientists, and they said, yes, there's a significant change. 72%, none of which, of course, are credible climate scientists, said no. This is entirely irresponsible by the American press. This type of nonsense has to stop. And why? Take a look at the next slide. Here's the public perception of anthropogenic change. 26% say yes, there's a significant human impact. 74% no. Guess where they get this information? From all the charlatans right here who the press interviews and writes about. So I think this is another sort of one of the many things we have to do when we operationalize these ideas. We have to make the press responsible. This is an unacceptable type of situation. Well, I guess, do I have any American friends here today? Well, anyway, if you've seen Fox News, you'll see the type of absolute trash they're feeding to the American public. Total trash on that news. And this is having a very significant impact on society. So we have to do something about communication. And in many ways, we can blame ourselves, as I just mentioned. It's time that we stood up and started letting our politicians know and other groups that enough is enough, and let's do something about it. Let's really let them know what's happening. So it's a time for action. Okay, how much time do I have left here then, Monique? Roughly. I just want to cover a few more slides before the questions. I actually have 3 or 4 minutes. Okay. I'm just going to flip ahead and look at a number of different slides here. Just 1 second. No, it's okay. I can see right here. It's going to flip ahead. Yeah, let me just flip ahead. Now, I have quite a few slides here where I actually get into, what are some of the effects on climate, what's happening around the world, and, what's happening with the ocean rises, extreme climate. I'm going to skip all those. I think we're all pretty familiar with the horror stories. what I mentioned before is let's somehow use analogies and metaphors and language intelligence. This is something from the National Geographic. They said, let me just show this one slide. Here's a weather on steroids. Steroids is a drug that athletes take in order to, try to perform better. It gives you extra energy and everything else, but because it's hard on the health of the athlete, they're of course banned. So, a baseball player takes steroids. This is, I guess, the most popular team sport in Japan. Is that correct? Okay, well, the player hits a home run. Well, was that home run from a good player, let's say to start with, due to that steroids? Well, we're not really quite sure. So, for example, if I took steroids and swung a bat, I can tell you I'm not going to hit a home run. It has to be a good player who's actually taking these drugs. So a huge hurricane wreaks an extreme flood. Maybe it is. Did the steroids cause the player to hit one specific home run? The question is, did additional CO2 emissions cause one extreme hurricane? We have these types of problems. However, over time, the player hits more and longer home runs than usual from the steroid use. And this is sort of what's happening then with climate change. Right? Overall, the magnitude and frequency of hurricanes increase from greenhouse gases. That's sort of an example of a nice analogy. We have the climate on steroids. Now, what's happening in the literature for shorter and shorter time periods, given the evidence that's being collected, the scientists are more convinced than ever that this is directly caused by human release of CO2 gases. So I'm going to flip ahead now to a few more slides here. Let me go here, just a sec here. What happened there? That should have worked. Try it again. Just one sec. Oh, yeah. Okay, here we are. Let's take a look now at some other solutions. As I mentioned, at the international level, what's really missing, and by far the most important if we're going to win this game, is, of course, some sort of international agreement that's actually going to work. What we need is a Kyoto Protocol with teeth. That's what's needed by far the most urgently right now. But here, let's take a look at some of the more specific solutions. Lifestyle changes. I understand after your massive earthquake and tsunami of 2011, and of course the tragedy of the nuclear power plant, is that you decided to cut back 20% in personal use and industrial commercial use of electricity. And apparently, as things are getting better, that 20% cutback has remained there. So that's a really good example of a lifestyle change. Energy efficiency, very important. Renewable energy, wind, solar, biofuels. Now, this is a little bit hard to stomach, I understand, right now in Japan. But if they're going to cut back significantly, at least for the next 60 years or so, we're going to need a very, very wide-scale use of nuclear power. There's no other solution out there that can handle the demand. So third generation now, that's improved light and heavy water systems. Canada has a CANDU reactor that was developed there. It's heavy water. Plus fourth generation fast breeders soon. They're efficient. They use nuclear waste. For example, the CANDU reactor from Canada can be used to take the waste from standard nuclear power plants, including the ones in Japan. It can take nuclear weapons and eat those. It's got a really robust design. So we have some good technical solutions, and these plants are quite safe. The risk caused by those is almost non-existent compared to the risk caused by the release of CO2 gases into the atmosphere. Once again, we have to make sure that that's communicated to the general public properly. So, right down here, even the environmentalists now, who many in the past were anti-nuclear, we can't phase out coal without nuclear power. It's simply not a physical reality. Okay, so that's one slide I wanted to show. Let me flip ahead two here. I think Germany's making a mistake. Part of their policy, I think, is correct. They're saying, well, let's go to renewables. I think that's laudable. And they want to phase out nuclear power. Hypocritical. Because the French have an outstanding nuclear power system. They'll simply buy their nuclear power from France. Why not have it under your own control? So I think this is more a political stance than it has to do with reality. So if they don't do that, they're going to have to build more coal plants to handle the base load. There's no other way to do it. The other systems can't handle it at the present time. So hopefully we'll all be realistic in the types of policies that we look at. Just going to flip to a few more here. Let me just see here. Maybe see, 95. Got the wrong one. Okay, let me just flip ahead one more. There's a lot of evidence, by the way, that's going on. Some of the slides that I have are taken from science papers where they take a look at what happened in the past. Let me just mention this very briefly. There's something called the PETM, as given at the top there. Masses of carbon about the size of current fossil fuels deposit were naturally released into the atmosphere about 55 million years ago. There are a number of theories as to why this happened, but they know for sure that caused a 5 to 9% increase in temperature in the world. Extreme climate change and widespread ecosystem devastation. They have all sorts of geological records and fossils from small animals to demonstrate that this is correct. It actually took 150,000 years for the Earth's systems, the oceans and forests, to absorb the excess carbon for the planet to cool. So from this evidence from the past, they know that CO2 drives climate change. So there's a lot of work that's been done like that. There's also a lot of work going on where they're building these, these systems models to take a look at what's happening around the world at the global level in terms of atmospheric systems. Then it goes down to regional level, and it goes down to the local level, right down to hydrology at the basin level. So that's sort of modeling systems in the future. But the reasons why they're giving us these warnings about what climate change can do has nothing to do with the models that can be used to model the system now. It's from historical evidence. This is pretty hard facts. So anyway, I have quite a few slides in those, but I'm going to mainly skip those. Let me just then summarize the presentation. So once again, the problem. Geological evidence, well, I had a slide there that mentioned a little bit about that, shows that higher CO2 levels in the atmosphere increase temperature and drive climate change. There's no argument whatsoever when you talk about something like this. No credible scientist who works in the area has said that this is not the case. None whatsoever. Absolutely zero. Destructive impacts on societal and natural systems, we're already seeing them now. The United States, very recently hit by Hurricane Sandy. Dramatic reductions in CO2 and other greenhouse gases are needed immediately. And as I mentioned, we need this below the 300 parts per million. So what is the overall solution? Well, let me, before I summarize this slide, just say something more about Japan. Japan, I think, has a key role to play in the whole climate change game. And the reason is quite simple. Japan, throughout its history, has suffered from natural hazards. Earthquakes, tsunami. Because your river basins are fairly short, they go from the mountains right into the sea, you have extreme flooding when you have heavy rainfall. Other systems in the world, it's not as extreme because there's more absorption. The river basins are much bigger and not as steep. So Japan has developed decision technology and physical technologies to handle these extreme events. Well, now what's happening on a global basis is the other countries of the world are experiencing extreme events. Hurricane Sandy in the United States. So Japan has a world leadership position when it comes to that. And for example, right here at the Disaster Prevention Research Institute, we have some real world experts. Tomorrow they're going to be launching a new risk type of institutes among 4 universities in Kumamoto. And I think that Japan, well, I'm looking forward to see Japan continuing to share these ideas with the world. You have a real role to play. And actually, there are a lot of other areas where we can learn a lot from Japan. I'm not going to go into them now. Let me mention one. Japan is already dealing with the problem of an aging population. Once again, the world can learn from that. But of a special importance is climate change. So please take the Kyoto Protocol. You've already taken it this far, and everything that you've learned to help the rest of the world. I think that's such an important role for Japan. And I cannot think of another country in the world who has a more important role to play than you, based upon your excellent knowledge and massive experience from the past. So that's just an aside. And that's why we're looking forward to this continued cooperation with Japan, such as our agreement with Kyoto University, University of Waterloo. I'm hoping through the Academy of Sciences in Japan that we can make good connections and take a look at these climate change problems. So that's just an aside. Keep up the good work and don't lose heart because we have to do something. So once again, just in summary, what is the overall solution? And think of this as an approach for looking at other types of problems that will jump out. It's not going to be only climate change. You know, I mentioned the ozone hole example. There are going to be other types of situations we'll have to deal with. First of all, we have to have responsible governance. I think the whole philosophical approach of systems thinking, or the latest jargon is system of systems engineering or system of systems approach, is a good one because people naturally understand that. You know, they draw pictures of the systems, they see them overlapping. It's a nice philosophical way to look at problems. We want it to be integrative and adaptive. What happens in this part of the system affects something that happens over there. So we have to go across systems. We can no longer have silo types of policy by government where, well, they deal with this part of the economy there, they deal with agriculture there, they deal with environmental problems here. It has to be all interconnected. And it has to be adaptive. With the Montreal Protocol, as new gases became known, or new chemicals rather, to affect the ozone hole, they were immediately banned. That's what we call being adaptive, an example of an adaptive policy. We want to reflect the value systems of stakeholders. This includes not only the current stakeholders, but nature, and also the future generations who aren't here right now. They're not even at the table yet, but we want them to be around in the future, so we have to consider their approach tool. And the nice thing overall, what are we trying to do? We're trying to achieve desirable systems goals, such as resiliency and robustness, sustainability, and fairness. Notice that the whole idea of ethics and values naturally falls out when you take a systems point of view. Now compare this to the present situation of the world, where they talk, it's almost in fairy tales. They talk about, well, we have to have economic growth. The gross domestic product has to increase. I mean, it just makes no sense because we know we have to cut back. We can no longer expand the way we are. And to continue with these types of fairy tales as if this is something to run society by doesn't make sense. Society has to be run by culture and value systems. And then a nice way to explain it overall is using the systems approach. The ethics and values naturally follow. So I think there has to be a whole attitude change. And once again, I think Japan is in a very good position, has already shown world leadership in this area. So I think that then is a good point to stop the presentation.